I made this generator in a previous video and it performed really well. If you haven't already, go and check out that video. It is really interesting. One downside with it was that I used a drill to drive it, which is like using 240 volts to get a peanut in comparison. Let's change that. Today, I made a hydroelectric generator. You can work with your garden hose and you can make it yourself. So, let's get started. The first thing is to get a wood that would be your base. After that, get 2 pieces of wood to glue them onto the board, as that would lift the generator, giving room for the turbine to spin. But we'll get to that later. So now, I glued the 2 pieces of wood onto the board and then got these triangular pieces to support the sides, because the generator is a bit heavy, and if the supports are not strong enough, the whole thing will collapse, and no one wants that. So I placed the generator on top of the support structures. I applied some glue on the structure to hold the generator, but obviously it's not going to hold firmly. So I went ahead to do the same thing I did for the support structures, which is adding some triangular supports or pieces. It really took me some time because I had to find the right spot to place the triangular pieces. I had to take measurements. I had to do all kinds of things just to see that it's done perfectly, in my opinion though. So after a lot of exercise, because that's what it is, after that we can see that it's now set for the task ahead. So I'll be using this bevel spur gear from an angle grinder, if I'm correct, as a driven gear, as that will attach to the shaft of the generator. It's loose on the shaft of the generator, so I used glue to put a paper cutout around the shaft till it fits the hole of the gear. Then I used super glue to secure them all together. And once that is done, it is now time to proceed to making the turbine necessary for this project, and I will do that using these rubber spoons. They are light and are easy to cut. I turned the spoons into this turbine here. If you want to know how to make one, just drop a comment. Now, I put a stick through the turbine and use some glue to hold them together. Now this looks absolutely beautiful. Even by blowing some air on it, it seems to do a good job. Now I got another gear that matches the small one. This one is going to fit on the shaft of the turbine. But first, let's make a support for the turbine to ride on. Now, this is just simple. All you need to do is to get some PVC, drill matching holes, and measure their parameters. And by parameters, I mean their distances or the positions that those supports would have to be so that the gear meshes correctly with each other. I use triangular pieces to hold the supports to stop them from bending or shaking once they are in motion. I used some PVC cutouts to make some kind of a stopper or a fin or something that limits or stops the turbine from moving back and forth while in motion. Now, that will also allow the gears not to slip or disengage. After gluing the supports, I went ahead to make the gear to fit the shaft as it's loose on it. So I did the same thing I did for the rotor of the generator, which is to add a paper cut or paper strip, glue it onto the shaft till it matches the hole on the gear. Once that part is done, it is time to move on to the next, which is to test the generator and see how it performs. Now, let me give you a close-up of what we have made. This is it, looking good, I would say. Now, the moment of truth. Will it actually spin? And it did. Well, I'm glad it did because this all really took a lot of time. I just love how clean this looks. Not the best, but it's clean for what it's worth. Pinching the hose makes the water to rush out at higher speeds and higher pressure, if that's important. What are we actually getting out of this? Hooking up the multimeter, turning on the hose, and we can see that it easily gets up to 15 volts. $30. Wow, isn't that impressive? Something like this. Wow, almost 43 volts. The drill was able to spin the generator up to 50 volts, and the drill is rated to be up to 3500 RPM. So, if this turbine was able to get this generator up to more than 40 volts, then it has to be that the generator spins at a speed of at least 3000 RPM. It is really impressive that it can get up to a decent voltage even at low RPM, which is ideal for a wind turbine. I think I will try that next time. So, for the meantime, this will be the end of this video. Remember to like and subscribe and comment if you want to know how to make that spoon.
Cause you're trying to stay strong and fake a smile until I look away.